going to record this practical. Okay. Anyway, I have to upload now. Right. So this is practical. Our objective is to determine the viscosity, right? In different temperature, and you have to plot, right? If you know that data, I will give you that observation data. Using those data, you have to plot the graph, right? Two different graphs, right? Because there are two different viscosities, right? Dynamic viscosity and kinematic viscosity, right? We will see what are the viscosities, and this is the mail. Disandan123@gmail.com, right? Don't send anything to any mail, any other mail. So please send anything regarding absenteeism or any regarding any class clarification, or let's say if you don't submit the report, if you couldn't submit the report, or if you do, because of the lateness we couldn't submit the report, let's say, then you should contact me through this mail, right? Tisana123@gmail.com, right? Then if you are absent, also send any medical or anything, the reason for evidence, you can send through this mail. When you are mailing me, please clearly mention your index number and name, right? So that will be the right way, right? Then only I can identify your index number. Then if you have proper reason and evidence, then I will consider it. Okay. So send this mail, right? Tisandam123@gmail.com. Okay. Yeah. Total answer sheet. Yeah. Okay. I will send it. Okay. Then tutorial. Okay. Now then I will send this tutorial answer PDF in LMS, right? I will upload it today, right? Within today, I will upload it. Check it there, and if you want, take it there, right? So this practical is about find out how to derive the viscosity, right? In different temperature. So today's practical about new oil, right? The oil number is SA15W40, right? 40 oil. We just when we are talking, we say it as 40 oil, 50 oil, like that, right? We say the number of the oil, right? So what is viscosity, right? Viscosity is defined as a resistance to flow, right? When the flow is flowing, you can see if one fluid is viscosity in a high, the one fluid is viscosity high, then there will be the flow speed is very low, right? Or let's say we can take one example: water and honey oil, anything, right? Other than water, the honey have high viscosity, right? Therefore, if we pour 1 cup of water and honey, what will happen? The honey will flows very slow, right, compared to water. But water will be flow very quickly, right? So because there will be because of the difference of the viscosity, they will react differently, right? So I have a video, so it will give you any, I think give you that clear idea about this one, I think. So I will show it to you. Okay. First, we will understand the viscosity, right? What is the viscosity, right? If you want to understand the viscosity deeply, we should go into that molecular level, right? So I think Yes, I'm playing. So, can you hear this video on?
No, sir.
No.
Force between molecules.
Can you hear now?
Yes, sir.
This is the here they will explain about this viscosity in molecular level, right? So we should understand there will be a small difference between solid and liquid, right? That is depend on the bio rating, right, movement of the molecule, right?
As we heat the solid, this attractive force becomes less effective because of increased vibration of molecules because of heat energy.
Yeah, when we heating that solid, right? Let's say ice cube, right? Then the water molecule, what will happen? There will be a small distance between water molecule, and also the molecule have small vibration, right? Less vibration. That means they have less energy. What will happen is when we heat up, right? When we heating up, we are supplying the energy. That means the molecule absorb that heat energy and vibrate it more, right? Then it will have the uh, more vibrating energy. That means it will move very high, right, compared to before.
As the attractive force becomes less and less effective, movement of particles relative to each other starts. Addition of
Yeah, when we supply the energy, heat energy, what will happen is the movement is start to move, right? Movement is become very high and high because it have that molecule have high energy now. Molecule absorbing continuously absorbing energy, right? When the energy of the molecule energy increases, it will vibrate more and more, right? Then there will be more space. Then it will form that solid become liquid, right?
more and more energy results in more and more movements, and solid starts converting to liquid.
When the molecule get after some point it will become as liquid, right?
For a given temperature, different liquids showcase different magnitude of relative movement between molecules. This relative movement is measured in terms of physical quantity called viscosity.
Yeah, the viscosity here we have viscosity is come. If that movement, we can say if it is water or if it is honey or if it is oil, right? Then if a certain temperature, water have the higher movement than compared to honey or oil, right? If we compare the water and oil, both are liquid now. But if we compare both in same temperature, let's say 50 degrees Celsius, would have higher movement than oil because would have less viscosity. That means water molecule have less force attract water molecules attacks less than compared to oil, right? That is viscosity.
A liquid is more viscous when there is strong attraction force and relative movement of particles is less.
Yeah, when it's more viscous, that means less force, right? Less movement, that means high force, right? If it is this one is honey, right? Let's say this honey, then what is happening? There will be that molecular force will be high. Then there will be less movement. That will be the more viscosity, high viscosity, right? Scenario. If it is water, then that molecular attraction force will be less. Then there will be the movement is high, right? The molecular movement vibration will be high. Then that will be low viscosity.
And a liquid is less viscous when there is less attraction force between molecules and there is an easy movement of particles relative to each other.
Yeah, when it's less viscosity, then easily there will be less attraction force between that molecule. Then there will be easy movement, and the movement moving length also high, and because of the less force, attraction force, right? Weak force between the molecules. So that will be less viscosity, right?
If we compare engine oil and water, engine oil is more viscous force compared to water.
Yeah, engine oil viscous more, higher than this water with a certain temperature, because that molecule of engine oil have more attractive force, right, than compared to water, right? Water molecule. Therefore, it is high viscous.
Now let's understand what happens when a solid object moves in or on the liquid. Now, imagine a boat is moving on water. With boat, water molecules on top layer are also moving.
Yeah, you should know that if you want to understand that behavior of the liquid, right? So you should know look into the layer by layer, right? So you can see when the boat is moving, that first layer, that which is touched with the water, also move. But if we look at other second and third layers, there will be less movement, because in the downside, bottom side, there will be a lower, that there will be another layer, no? That layer will be attached with the bottom part. That one move, that is steady, no? Therefore, each molecule have the attract force. Therefore, that which is the first layer will be move, right, very fast. Other one will be less fast, and other one more less. That finally that bottom layer will be zero velocity, right? That will stay with the bottom part, right? There will be, because the bottom line is no, there will be no movement in bottom line, right? The seabed, right? So then that layer will be attached with that seabed, right? But you can see the boat should be give force according to the boat is only need the first layer, right? Because the boat is moving with the first layer, right? But when the first layer is moving, there will be force need to move this molecules, right, from the second layer and third layer, right? Because there will be attraction or molecular attraction. There will be that force given by the motor, right, which is fixing the boat, right?
As we move deeper and deeper, movement of particles reduces. Since there is an attractive force between molecules, deeper molecules try to prevent surface particles to move with boat.
Yeah.
And to overcome this force, boat need to apply more force. Force which prevents relative movement of particles or layers of liquid is called viscous force.
This is viscous force.
More the viscous
force means that attraction between two molecules, right?
More will be the viscous force, and more efforts one needs to put to move layers of liquid on top of each other.
Don't confuse with this.
If we drive boats on oil and
You just
water,
need to know this one, right? If you drive the boat in oil, other scenarios we are going to drive the boat in water, right? Which need high force, right? You know, right? This molecule have high force now between two molecules. So if you want to move the first layer of the molecule in the oil, we need high force, high energy, because there will be high viscous force or high attraction, right? Force between two molecules compared to water.
boat on oil will consume more fuel because oil is more viscous compared to water, and thus more energy will be required to overcome this force.
Right? I just play this video for you should know the one example, right, where we are playing this viscous. Right? Then when we have this, yeah, yeah, uh, yeah, when we drive the boat in fresh water and salt water, there will be a difference, right? If it is salt water, there will be this viscosity is little high. So there will be we need more energy or more fuel in when we drive the salt water. Then if we try the boat in salt water, lake or anything, then that is east compared to sea, right? Ocean. Right? So that should be that should you know that one, right? So there will be a that it will impact, it will affect according to the viscous of that fluid, right? Where we drive the boat, right? So this is the viscous, and there will be another video. I should know. You should know. You can see when we yeah apply some same amount of different fluid, right? Different viscous fluid. You can see that which have high viscosity, it will take less time, right? High time to pass this line, right? There will be line in that whiteboard, right? Whiteboard or white sheet. So they will, yeah, they'll. It is in not horizontal, but it is an angle, right? The same angle, but they are going to pour different fluid, right? And see which same amount of fluid. So see which is going first, going past this line firstly, and secondly, and third.
In the first heat of our race, we have water, rubbing alcohol, and cream. Water finishes first with a time of 0.233 seconds.
What as you can see, it is quickly passed because it has less viscous compared to other things. So when we pour water, what is happening? Quickly pass within 0.233 seconds. This is dropping alcohol. Right? Alcohol is less viscous compared to water. Therefore, it took little high time. The cream also.
And rubbing alcohol finishes last with a time.
Yeah, cream also a little higher than the water and lower than the alcohol.
Time of 0.4 seconds. In the second heat of our race, we're going to be racing.
They are going to do it again for another three different oils: olive oil, lamp oil, vegetable oil. So within oil also we can differentiate the viscous.
Olive oil, lamp oil, and vegetable oil. Lamp oil finished first with a time of 0.467, and olive oil finished last with the time of 0.633 seconds. In the final heat of our race, we're going to be racing honey, maple syrup, corn syrup, and dish soap. First,
here you can see this is honey, this is a syrup. I think one of the syrup or something. Both are syrup. This is soap, right? Dish soap. The honey has high viscous, no? Therefore, it takes. Still, there's past 1 second, but still, it won't cross this line. See.
across the finish line is maple syrup with a time of 1.33 seconds, followed by the blue dish soap with a time of 4.633 seconds.
Honey is still
And then
cool.
slowly but surely, the great corn syrup crosses the line with a 19.5 seconds. And then finally, honey.
Finally, honey reaches this line, cross this line after 20 seconds, right? That means they have high viscous. That means high attraction force between two molecules, honey molecules, right? Therefore, it is moving very slow, right? That is what you need to know, and we can compare this viscous. If we can take same sample and we can check it in two different temperatures.
With a 20.767 seconds.
I think you all know when the temperature is increasing, viscous will become low, right?
Here are the results of our race. Water crossed the finish line first.
Water is very low viscous. Honey is very high within these samples, right?
Meaning that this experiment enough that they are of the same type, giving the liquid gain energy, move further apart.
Okay. Here they are going to check again. Same sample but two different temperatures. This is warm, that means hot honey. That means this honey is temperature is higher than this one, right? So see.
And the cohesive forces between the honey molecules becomes weaker, decreasing.
Yeah, because when we change the temperature also, it will directly affecting the viscous of the fluid, right? So you can see it is just float like water, but here this one is take
Viscosity and increasing its flow rate. On the other hand, if we cool honey, the particles lose energy to the outside environment, move closer together, and
if you call the honey, what is happening? It take more, right? Viscous again or higher, right? If we increase the temperature, viscous will be reduced gradually, right?
the forces between the honey molecules become stronger, increasing its viscosity and decreasing its flow rate.
Well, that was liquid viscosity races.
Yeah. Okay. This is what you need to understand to get to know about this viscous, right? So I think now you all understood, right? What is viscous, right? But there we are using viscous for moving fluid, no? So that is exactly the viscous, right? We can say it as dynamic viscosity, absolute viscosity, or we can just call it as viscosity. Yeah, that is that is what is so what we saw in these videos, right? So that that will not like this, right? Just we'll call it as viscosity, or we can call it as dynamic viscosity, because it is always moving, right? That should be the viscosity, right? And the other one we call it as dynamic viscosity. But here what is the difference is we just divide this viscosity by the density of the fluid, then that will be the kinematic viscosity. And only these two are the main difference, right? Two type of viscosity you should know, right? Dynamic, or just call it as viscosity, and kinematic viscosity, right? Absolute viscosity and kinematic viscosity. Those two are the viscosity types you should know, right? That the notations also you should know, right? This is a viscosity notation, right? And small v for the kinematic viscosity. The small v is equal to that viscosity over the absolute viscosity over density, right? Okay. So now we'll look into the apparatus. So after explaining the apparatus, I will show a video, right? Recorded video, and we will move to the observation data and I'll explain later that how you are going to submit the report and how you are going to do the calculation and how you are going to plot the graph, right? This is the apparatus which we are going to uh, use to determine the viscosity of the fluid, right? This is digital redwood viscometer. We call it as digital redwood viscometer. So I think you are clear about this noise, my sound and everything. If you have any difficulties about if you want to increase the volume or decrease the volume, you can just say, right? If you not able to understand also, you can say explain, right? Just or just put some message in, just in the chat box. So this is a digital one. So directly we'll get the viscometer. So not viscometer, here we'll get the temperature, right? But manually there's options to measure the temperature manually, right? This is the redwood viscometer. You can see, right? Here the main parts you should know. There's two yeah, the same time here, same time we can measure the viscosity for two different samples, right? So but we have done one by one. So we have first we have done for the new oil. So we use this one, this cup, right? This side, right? Here you can see the I will explain the switches. This one is first one is that thermostat, a safety thermostat or heat controller. We can, so we say it as heat controller, right? This one, the black one, right? Rotating, like rotating switch, right? This is heat control, right? We are how when we want to apply more heat, we will rotate clockwise, right? Then there will be display, like display and digital thermo calculator, right? That black one, right? There we will set that temperature up to which temperature, up to the where we have to increase the temperature of this sample. So that will be, we will set those things in the digital thermo calculator, right? The black color one, right? Display, right? And also from this display we can measure the temperature of the water. Here you can see there's two that cup, right? Where we fill the sample, right? In that two cup is inside the water bath, right? This is a water bath or water tank. We can say that water tank or water bath, right? Inside this water bath, there's a two cylindrical cup, right? So in that cup we will pour the oil, right? Which sample for the sample of that specimen which we are going to measure the viscosity, right? We are going to measure the viscosity of the new oil. We have to pour some new oil here, right? Here or here, right? So but this cup is inside the water bath, right? So this heat will apply to the water first. Then after increasing the heat of the water, that heat will transfer from the water to sample, right? If it is oil, then water heat will be transferred from water to oil. So and here also manually also we can fix that thermometer to measure that. This one is to measure the temperature of the water, and here in the display also we can get the temperature of the water, right? Not the sample, right? If you want to measure the temperature of the sample, we should insert, right, one thermometer inside the sample, right? Then from the outside we can measure the temperature of the sample, right? So that shown in the picture I think. After, if you don't understand this one, don't worry, after watching the video you will understand better, right? this is a cross section of this red viscosity, right? This is a cross section, but here this is all our notes that exactly which we are going to do the digital viscometer. It is not the diagram for that one. Here you can see only if we consider one part, right? There is two samples we can do for the two samples simultaneously, but here only one sample they can do manually, right? This is the older one, I think. This is not the digital one. Here you can see in the middle part, you can see this is one of the brass cylinder, right? But other side, the both side covered by the water tank. Then heat will apply to the water, right? Then the heat will flow from the water to the sample through the brass cylindrical wall, right? Then the heat will flow through this wall. Then you can say after heating that, okay, if you want to find out the viscosity for 6 degrees Celsius, we can oil sample. We have oil sample, so we have to find out the viscosity of this oil sample in 3 different temperatures, let's say, right? 60 and 70 and 80 degrees Celsius, right? Then after increase this oil sample 6 degrees Celsius, then how we will find this viscosity for this oil in this temperature? Then after reaching the temperature, how we are going to find out the viscosity is just there's in that inside that the bottom of that cylinder, the brass cylinder, there's an orifice, right? Small hole, right? We call it as orifice. From that orifice, up to that, when we are reaching that up to that point temperature, when we are reaching, there will be there's time it takes, right? So up to that point, we have to close that orifice using one. It is like a ball valve, right? There's the orifice is downside of that ball, right? Ball shape, right? There will be small orifice. Then we can close that orifice using one valve, right? I will show you in that picture, in the video clearly. Using that orifice, we will first close that orifice, that hole. Then we will fill with that sample. Sample should be limited volume. That should be 50 milliliter, right? Here we use 50 milliliter sample. We should fill this cup with using 50 milliliter sample. Then heat up to the 60 degrees Celsius. Then after reaching that 60 degrees Celsius, we have to release that valve, and then through that hole, oil will flow to this cup, 50 milliliter cup, right? We have to collect this oil from the downside of this hole, right? Then just while collecting this oil, we have to measure the temperature. We should have the stopwatch. When we take out this valve, when we start to collect, we have to press the button, and up to reach the 50 milliliter level, we have to stop. We have to measure the temperature. How many seconds it took to fill this 50 milliliter, and we know that diameter of the orifice and everything using there's a equation for standard equation for the thread-foot viscometer apparatus. Then using that viscosity, that apparatus equation, we can directly calculate the viscosity, right? So let's say this is the observation data. I'll give you later. First, we will see the video, right? Just we have to measure here. What are the measurement we are going to do is just we have to measure the time taken to collect the 50 milliliter, right, from the downside, right? So that time will be reduced when we increase the temperature. You can see, right? Because the hole is same. When we increase in the temperature, what is happening is viscosity is become low. Therefore, to collect the 50 milliliter, it takes less time. right? So see what is there's an introduction of the machine operators. Just see. So I'm playing this video.
Okay, this is Redwood viscosity apparatus. So
Yeah, this is the viscosity apparatus. I think do you hear the sound of this video?
Yes, sir.
Okay. This is a viscosity Redwood viscometer, right? Which used to measure the viscosity of the fluid, right? Here first we are going to only there are two cylindrical parts. I told you. The same time with the same time we can measure the viscosity of two different samples. But here we are going to use this one hole only, right? This one cylindrical part. So using for this one, first we are going to measure the viscosity of the new oil, right? SI40 in 3 different temperatures, right? 60 degrees, 70 degree, and 80 degrees Celsius, right? Here I will show for 1 degree Celsius for one set of data how we are going to calculate. But I did for everything, and I have recorded, and I will give the data. Then using the data, you have to do a calculation and everything. I will explain later. Let's see. This is the introduction. So how we are going to use and what are the switches and why we are using these thermometers and everything.
this is used to determine the viscosity for the lubricant oils. Here we are going to determine the viscosity for the new oil and the juiced oil.
So first
So
we are going to
first I will explain
for this new
about this apparatus. Here
first understand this
you can see
apparatus,
there are
okay?
two thermometer. This is water tank.
This one is water bath, right? Water tank. Inside inside this bath or inside this water tank, right? Here there's a cap. No, this from this after removing this cap, by removing this cap, we can fill the water here, just water, right? And here this after removing this cap, we can fill the sample, right? There are two cylinders in this water bath, right? And here one thermometer and here one thermometer. Why it is here is this thermometer tell the temperature of the water. This will tell the temperature of the sample oil, right? There is a small difference because first the heat will flow to the water, then the heat will flow to the water from the water to sample oil. So there will be a small time, right, to reach the temperature from the water to oil, right? So that we have to give some time to flow the temperature also, right?
Inside this water tank there is a cylindrical cup where we put our sample. There are two cups, so simultaneously we can do we can derive viscosity for two samples. So here you can see
You can see in this cup there is a orifice, right? Small hole, right? And this hole is under one shape of that spherical shape one, right? After become the spherical shape, there is a small hole down there, right?
inside this cup there's a
This hub is under the middle of the water bath, right?
orifice. So after heating up the sample, we will collect this oil sample from the bottom side.
Right.
So at the same time we will measure the time to collect 50 milliliter oil sample.
This is a downside bar, the bottom side. And from here we can collect.
Here
This is the 50 milliliter
this is the first sample which we are going to measure the viscosity. This is a new oil.
you can see there's a limit, right? There's a mark. So it is already marked the volume, right? So we know this where it is, how much 50 milliliter is. So we should take 50 milliliter exactly, then put it to one one cylindrical cup, right, which we are going to use to measure this viscosity. So after putting this one, when we are putting, we have to close that orifice, that hole, right, using ball valve, right? I'm sorry.
Here you can see this is the marking point. Up to this is 50 milliliter. How to operate this apparatus? So heating controller, we can
This is a heat control, right? You can see 10 degrees Celsius, 20, 30, 40, 50, 90, 10, 100, right? Up to 120 we can heat this water, right? If we can heat up with water up to 120, then we can keep this sample also up to 120 degrees Celsius, right? So here we need to take time, right? By measuring the time to collect 50 milliliter, we can derive the viscosity. So we have equation for this apparatus. So using that equation, if you know the time to collect 50 milliliter through that orifice, we can measure the viscosity for that certain the collected temperature, right?
heat up this water inside the tank. And we need to measure the temperature of oil and the water. This will connect with this water which is inside this tank. So here from the outside we can measure the water temperature, and here we can measure the sample oil temperature. So this is the main switch, and here this is a digital thermo calculator. From here also we can observe the temperature of the water, right? But we have to give some time to transfer the heat from water to oil sample. So now we'll heat up to some degree Celsius, then we will collect 50 milliliter oil sample and measure the time 50 milliliter through that orifice. This in the lab sheet, so we can okay. Now we will fill our sample in that cylindrical cup, and we will start. We will heat up. We will make the temperature as 80 degrees Celsius. Then we will collect this oil. So first I have to.
Already I have done 60 and 70 degrees Celsius. So now we are going to done for the 80 degrees Celsius, right? So after every time when let's say we are going to measure the viscosity for the 60 degrees Celsius, then we have to put the sample here and heat this sample up to 60 degrees Celsius. Then after reaching the 60 degrees Celsius, from this thermometer we can observe, no? After reaching the 60 degrees Celsius, we have to start this start to collect from the downside and start at the same time start the stopwatch. Then we can by measuring the temperature, measuring the time to collect that 50 milliliter in that certain temperature, we can derive the viscosity, right? Then again we have to put that sample again into this cylinder, then heat up to 70 degrees Celsius. Then after reaching the 70 degrees Celsius, we have to again collect the sample at 70 degrees Celsius. And while collecting, we have to measure the time taken to collect a 50 milliliter sample. Then using that time, we can measure the viscosity at 70 degrees Celsius. Like that, again we have to put and again heat up to 80 degrees Celsius. Like that, in every different temperatures, we can. If you know that the time to collect 50 milliliter, we can measure the viscosity.
Pour this oil. So
This is how we put oil and measure the temperature.
here you can see
Here you can see
temperature
the
750, and this one
valve.
is ball valve. You can see this ball valve is
This is like ball, right?
block the oil flow, right? This will block the oil flow, right? If we took this ball valve, the oil will flow down to the cup, right? So we can collect, right?
You can see that that orifice, that small hole is the bottom of that the spherical shape one, right? Spherical shape, right? So that this ball will be when we are putting this ball, that will be block the flow of the oil, right? Then when we start to collect, we have to hook up this oil ball valve. Then we can start to collect. At the same time, when we are hooking this ball valve, we have to press the button of that stopwatch, right?
So before, when we are heating, we have to block this orifice using this ball valve. So now I am going to pour this oil.
Yeah, I have already filled some oil, right? Therefore, use of that oil, right? But when we are doing the practical, if we are to close using that ball valve, then we have to fill the sample, 50 milliliter sample in the cup, right?
Now we have pour this 50 milliliter oil inside this cup. So now we can close. You can see now this is this will block the oil flow. So after heating up oil, then we can took this up, this ball valve, then we can collect the oil from the downside, right?
Because there's a stand, it is like stand, right? When we
By
hook
using
up this
thermometer, we can
oil
measure
valve,
the
we
temperature.
can hook the ball valve and stand in that stand, right? It's in stand. Then the oil will be flow continuously. Then we can collect from the downside, right?
From the outside, right? This from this apartment, we will.
You can see here that where the oil is flow down, right? Here from the orifice, that hole, oil will flow down here. So we have that 50 millimeter cup, the measuring cup. So using that cup, we will collect here.
Collect the oil, right? Again, we will use same cup, 50 milliliter cup. Then after heating up the oil, we will plug up that ball valve. Then we will collect the oil here. When we are collecting, we have to measure the time for the 50 milliliter oil, right? For that, we will use stopwatch. So now we will start. So first we have to press the main switch. Then we have to using this heating controller. We have to make it
now it is 60,
which temperature
degrees
up
Celsius.
to which temperature we have to increase, right? So I now I have to increase this temperature up to 80, around 80 degrees Celsius. Then in that temperature we will collect this 50 millimeter oil sample, measure the temperature, measure the time taken to collect those sample. Right? So
Then up to 8 degrees Celsius, we have
this
to heat.
straighter,
This straighter, right?
it is
This
used to mix
it is used to mix the water. This is there will be more water bath now, water tank. So when we are heating the water, the heater will be heat the water. Then there will be a straightener to heat flow the heat throughout this every side of this water, every part of this water. Then only it will then only it will flow uh, steadily through that cylindrical the brass metal, right, to that sample, right. Therefore that we should supply the heat homogeneously, so therefore we use straightener. For the previous practical also we are, you know, that there is a straightener, right.
water, so that heat flow will be heat will flow simultaneously and homogeneously, so that 66.
Right. Now we will last video, final video. So in the meet of the yeah, you can leave, but 0 to 22 you can leave. Then mail me your yeah, mail me your that medicals and everything, right. While you are in the hospital, if you are in hospital or if you meet a doctor, there will be a receipt or there will be evidence, no. Then just send me the evidence, then no problem. So we'll measure that collect oil in 80 degrees Celsius, and measure the time taken to collect this oil, right.
Now you can
Now
see it is
you can see it is 80 degrees
around
Celsius.
80 degrees Celsius. So
That means the water temperature is 80, but we don't know how much temperature, how much heat flow to this sample oil, right. So we should look at the temperature of the sample oil.
this from this thermometer also you can see it is 80 degrees Celsius. But
It's the water temperature, right. So water temperature we
right,
can say,
when
we can see through this to using this thermometer or that thermocalculator, using this display, right. Both should be the same temperature, because both represent the water temperature.
reach the temperature, we have to stop that heater, right?
When
To
we
stop
reach
the
that
further
temperature, required temperature, we need to we need 80 degrees Celsius, no? Then when we reach that, we have to stop. That means we have to rotate other the counterclockwise, right.
heating. So here you can see it is 80 degrees Celsius. This is water temperature. In that water tank, this oil sample is here in middle of this water tank. So you can see it is
You can see it is not yeah, it is like 70, between 75 and 80, 76, like it is like 76 degrees Celsius. Why it is lesser than temperature is lesser than that water? Because the it took some time to transfer the heat, right, from water to sample oil. So we should give some time.
around 76 degrees Celsius, right?
So we let some time. Then it came to
Oil
the 80
sample
degrees
reached
Celsius.
to 80
You
degrees
can say now
Celsius.
it is 80
So
degrees
now
Celsius.
we can start to
Then now we heat up this oil sample up to 80 degrees Celsius. Now we can start to collect the sample, right.
collect the oil sample. Here you can see, right? I already explained, under this cylinder there is a oil orifice hole. So we have to place this cup under this orifice hole. So after when we remove this ball valve, we can start to collect the oil sample.
While we removing the ball valve, we have to start the stopwatch. That is the point we are start to collect, right? When we removing, we have to start the stopwatch, and we have to let run the stopwatch up to that the level, right? 50 milliliter level.
So that while we remove the time also, here we are going to find out the time to collect 50 milliliter oil sample in this temperature.
Here what the data we need is, we need the time, how much seconds it took to collect the 50 milliliter through that core, right? Through that orifice. That is what we need.
So while taking this take out this ball valve, I have to press this
So
so turn this out, we can hook this ball valve in here.
now you can say
Apartment, you
the
can
oil is flowing now.
oil will
At
oil
the
is
same time,
flowing
the time is running.
through that orifice
Right?
to this cup,
The time also running. Okay,
and we have
you can see the 30 second, 31 second, right? Up to this limit, we have to run this time, right? Right. Okay. When we reach this limit, I stopped, right? The time is 3.40, right? That means 3 minutes and 40 seconds. That means 3 into 6, 180 plus 40, 220 second, 220.22. We can calculate the 22. So altogether there are 220, right? 220 seconds to collect this 50 milliliter at 80 degrees Celsius. Then if we know that temperatures, time, we can measure, we can using the as a equation, I'll show it to you. We can measure the viscosity at 80 degrees Celsius, right? That's it. That's it. That's it. I think, do you all understood how we do this practical, right? Here we are just measuring the time, right? Time to collect the data, right? This is the observation, right? Our observation, right? We just done for the 80 degrees Celsius, right? So you can see the 221, right? 220, I think, for 220.444 something. So it is 221 for 80 degrees Celsius. Likewise, before recording the video, I have done for 60 degrees Celsius and 70 degrees Celsius. So 60 degrees Celsius, it took 448 seconds. For 70 degrees Celsius, it took 313 seconds. For 80 degrees Celsius, it took 221 seconds. Why this time is become less and less, the decrease, why it is decreasing, is because when the temperature is increasing, that viscosity is decreased, right? When the viscosity is decreasing, the oil flow rate through that orifice is increasing. Therefore, to collect the same amount of 50 milliliter, it took only less time compared to other temperatures, right? So I think the density of the oil is 0.85 gram per centimeter cube, right? You should use density. Yeah, you should assume density will not change in these three different temperatures. Okay, so please write down this temperature density 0.85 gram per centimeter cube, right? This is for the new oil, right? For the new oil, because you need this density for the calculation, right? I think you will note down. So this is a table, calculation table, right? Your table in your lab sheet. You can look later, or you can see, right? This is you have to do, right? For the lab report, right? This is a calculation table. Here, A and B they have given. One is that orifice diameter. Other one is that the orifice is under that ball shape, no? That under that spherical shape, right? That diameter is 1.72, right? They have given two. This is just remember, you don't need to know because it will change according to the apparatus. Here we use that Redwood viscometer, one digital Redwood viscometer, one type of apparatus. It doesn't matter. So they have given equation for the apparatus. V is equal to the if we want to know the kinematic viscosity. This is the viscosity normal, that normal absolute viscosity over density. That will be the kinematic viscosity. They have given the equation, one equation for to derive the kinematic viscosity directly. Just we need to know the time, the seconds to collect 50 milliliter. If you know that one, just they have given that their constants A and B. This is minus T. There is a T, no, but the both T will be the time taken to collect the temperature. That in the 60 degrees Celsius, the time is 448 seconds, right? The time is 448 seconds. So for the T, you will put 448. Here also you will put 448. Every time you should put in second. You should know. And B should be 1.72, and all other equations are in centimeter. The length is every length and cross-sectional area is in centimeters, right? Therefore, the density also in gram per centimeter cube. No, therefore you can put B as 1.72, A as 0.0026, right? Then you can calculate the kinematic viscosity, small b. This you can calculate and put here, right? Likewise, you have to calculate for these three different temperatures, right? And then density, you have to take this density, that is new oil density as 0.85 gram per centimeter. Right, in your lab sheet, they have that unit is wrong. They have put gram per second. That density should be gram per centimeter cube or kilogram per meter cube. But here we got to use for this equation, we have to use gram per centimeter cube. So 0.85, right? All these three different temperatures. We assume, but there will be a small change in density also when we are changing the temperature. But we assume there will be no change. Okay. So now just applying this constant and the time that you measured, you can calculate the dynamic viscosity B. Then if you know the density, just you know that kinematic viscosity is viscosity over absolute viscosity over density now. So if you know the kinematic viscosity and density, you can just by multiplying this viscosity, that density kinematic viscosity and multiply by the density is equal to absolute viscosity, right? Then you will get the absolute viscosity. Likewise, you have to derive this kinematic viscosity and absolute viscosity for these three different temperatures. right? Now you know this temperature, 3 different temperature, and for that 3 different temperature, you can calculate the 3 different kinematic viscosity. Then you will calculate the 3 different absolute viscosity or viscosity, right? So you should plot the graph, right? For temperature versus kinematic viscosity and temperature versus absolute viscosity, right? 2 different viscosities in 3 different temperatures, right? Uh, do you understand this? What you are going to do? Please tell anyone, guys. Do you understand?
Yes, sir.
So this is a simple calculation. Okay, don't worry about this. Everyone should plot this, draw this table, and you have to do, right? And calculation is very simple, right? Just put a, a and b constants, and then you know the time taken. I have given time now. So this would be this. Can you note it down this time? This observation. Please note this down. This observation. Temperature and time taken to fill 50 milliliter flask, right? So time taken to collect that 50 milliliter oil, right? In 60 degrees Celsius, 448 seconds, 70 degrees Celsius, 313 seconds, 80 degrees Celsius, 221 seconds. Please note this down and write this down also. This oil, right? That density of oil. This will be you will know these things, right? You should know to do this calculation. Please write it down. So okay, have you write it down? Everyone, okay? If you are done, then we will move to the next part. Or discussion part and everything. Did you write this one? Did you write this data?
Yes, sir.
Okay. Then just these things, these tables and everything you have in the lab sheet. Don't worry, right? Same. Just draw same that format calculation table and do it, right? Then lastly, you have to do the lab report, right? Lab report writing in the lab report, and you have to plot the graph. No, to plot the graph, the viscosity, 2 different viscosities. No, kinematic. Here you are going to when you are applying using the apply directly this equation, you will get the viscosity, kinematic viscosity. So you should plot the graph temperature versus kinematic viscosity. One set of graph. Other graph, second graph is temperature versus absolute viscosity. 2 different graphs. Here, which one is x-axis, which one is y-axis? Do you think? Okay, tell me. Who is 092? 092? Okay, 092. Okay, 064. 064. Do you there? Are you there? Jeniston. Jeniston, are you there? If you don't talk, I will put absent, okay? If you don't talk, you may, no problem, right? You can just move your mic and just stay, or you can left. I don't know you already left or not, but you will get absent, okay? So 0.64 last time. No. 0.92. 0.92. 0.92 absent. Do you absent? Okay. 0.47.
Yes, sir.
0.47. Okay. So what is your number? Just okay. 0.47. What is your name? Lakmal. Okay. Then Lakmal, tell me. So if you are first we are going to plot the graph, temperature versus. You can see this table, right? Slide. You can see, no? You are going to first plot the graph, temperature versus kinematic velocity, right? Sorry, viscosity. Temperature versus kinematic viscosity, right? Which is x-axis, which is y-axis. Do you think?
Temperature x-axis.
Yeah, I'm telling x-axis is what we are changing, right? X-axis is always what we are changing there, right? What we measure was what we found out in final, what we derive as data, that will be y-axis most of the time, right? So what we are changing is temperature, what we are changing. So x-axis should be temperature. Yeah, that's what you said, right?
Yes.
Okay, very good. Then first plot should be temperature versus kinematic viscosity. Temperature is x-axis, kinematic viscosity is y-axis. Just three set of data. Just you can put three dot and write the row of graph, right? So the second graph is temperature versus, again temperature will be the x-axis, y-axis is absolute viscosity, right? Okay. So now you can do this calculation and everything. If you have, if anyone have any not clear with this, how to do this calculation, if anything, what I have explained it now until now, if you don't clear or don't understand anything, just ask now. So this is the lab report writing part. So these three questions are in your lab sheet also. And plot, there are two graphs now: kinematic viscosity versus temperature, absolute viscosity versus temperature, and theory, right? In the theory, you can include what is the type of viscosities, what is kinematic viscosity, what is absolute viscosity, yeah, why we use viscosities, right? Yeah, you can include anything. Then the first discussion question is discuss the results. After plotting the graph, you have to discuss. Yeah, with the temperature, what is happening to this kind of viscosity, and with the temperature increases, what is happening to the absolute viscosity? You can discuss, right? And both comparing both graph also you can discuss if you want, and discuss how a cold day affect the performance of the vehicle in terms of lubrication, right? Inside the vehicle there is a lubricant oil now we are using, engine oil. So what is happening if it is a cold day? That means if the temperature is decreasing, that engine of the when the inside when the oil is inside the engine, it can be anywhere, right? When the climate is very cold, the oil temperature will be very low. When we then what is happening, right? When we are driving that vehicle in the cold climate, what is happening? Discuss about the importance of viscosity of lubricant oil in automobile, and discuss about SAE numbering, right? That what is SAE 40, SAE 15, SAE 40, SAE 50, the numbering, how we number the oil, right? Different oils, right? That is called SAE numbering. So discuss about that. And what is the importance of viscosity, right? You can just explain, right? And application also you can write, right? What's the importance, right? And SAE number. There are three discussion part and two plots, right? Two graphs. and theory, right? The calculation parts would be included. That right? That calculation parts would be included. That calculation table, right? That observation table and calculation table should be there, right? If you want, you can write down the calculation for one set of data. It's just applying, yeah, you know everything that in fact every part of the equation, just applying the value by applying the value, you can just derive the viscosity, right? Dynamic viscosity. So now it is time to ask the discussion part. It is time to discuss any regarding this session, practical session. Or you can ask any doubts. Or if you don't understand how you are going to write this report, you can ask now. So I'll give some time while I am taking your attendance. 064. I there? Yes or no? If you say yes, then I will put present. Okay, 064 absent. 022.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
092.
Sorry, sir. I'm 022. Sorry.
Okay. I put present. Okay, no problem. 092. Okay. No response. 047.
Yes, sir.
Okay. Zero 48.
Yes, sir.
096. 096. 070. 070.
Yes, sir.
Okay.
Yes, sir.
039. 039. 018.
Yes, sir.
Send the last result. 008.
Yes, sir.
058. Okay. 027. 027.
Yes, sir.
055.
Yes, sir.
019. 019. 019. 002.
Yes, sir.
028.
Yes, sir.
018.
Yes, sir.
024.
Yes, sir.
74.
Yes, sir.
022. 022 again. Answer. Okay. Okay. If anyone I didn't call, please tell your index number.
Sir, 094. Sir, 053.
094. 053.
Yes, sir.
Okay. 1, 2, 3.
Sir, 094.
Oh, 94. Okay, I write it. Okay. 053 and
Sir,
0. Sorry, 0.
44.
044.
Yes, sir.
Okay, 044. Any other than that one? I will read it. If you are anyone without this this list, please tell your index number. 092, 047, 064, 022, 048, 096, 070, 039, 018, 08, 058, 027, 055, 019.
Sir.
Yeah.
27, sir. I say
Okay.
34, sir.
So, okay. 002, 028, 018, 024, 074, 094, 053, 044, 027. Okay. These are the presents.
Sir, 055.
Yeah, you have already noted.
Okay.
Sir,
48.
022.
53.
48. Okay, 48. Okay.
Sir,
022.
022.
Yes, sir.
22 noted. But you answer no.
52.
Sir.
But before I asked whether you are you were there or not. I didn't get any response. But
No, sir. I said reply for 92, but then you said I said 22, sir. Then you said okay.
Okay, no problem. So this your work, right, for your lab report submission. I think I didn't get any question. Please, if you have any question, please write in the chat box regarding this anything, writing this lab report or about this session. If you don't understand anything, please write here. So first theory, other one is you have to plot two graphs, right? Both graphs, x-axis temperature, y-axis kinematic viscosity and absolute viscosity. Then you have to discuss the results using those graphs. Then you have to answer these two questions, right? How this vehicle perform, right? How this lubricant affect, right, performance regarding when the vehicle is in cold day, right? Or when the vehicle is cold, how the viscosity will affect the performance of the vehicle. You can write. Okay? Discuss about the importance of vehicle viscosity and then what is the SI number. And here you should include the template, the observation table and calculation table, right? So are you all clear with this?
Yes, sir.
Yes.
Okay.
Okay.